So uh, DDoS or distributed denial of service is type of DOS attack that comes from many distributed sources, such as botnet DDoS attacks. So we are coming into the that part. What is botnet, right? But how does a DDoS attack work? So there are many way it can happen, right? The primary focus of the DOS attack is actually the oversaturated the capacity, right? So guys, there is when we are run a machine, there is the machine has some capacity, right? It has limitation of the RAM, it has limitation of the hard disk, it has the limitation of the bandwidth, right? So actually, when DOS attack happen or DDoS attack happen, it actually saturated all the things, right? And what happened when the server or the network device is saturated by the attack? Then normal service behavior would hamper, and normal traffic cannot pass through, right? And service the normal legit traffic will be hampered, right? So the main target of the DOS and DDoS attack is that, right? So typically, two there is typically two type of DOS attack, not DDoS. So that's the first one is buffer overflow. Let me write down. First one is buffer overflow. So what is actually the buffer overflow? It's a kind of attack in where it actually uh, buffer memory overflow the memory, right? So an attack type which a memory buffer can consume all the available disk space, memory, CPU, like that, right? So this form of exploit or attack can disrupting normal behavior of the server side, that calls the buffer overflow. That means it's actually consuming all the available resources like disk space, memory space, or CPU time, whatever, or we call that, right? So it's called the buffer overflow attacks. And what is the flood attacks? So another type is flood attacks. What is the flood attacks? It's the same. Main when we are talking about the DOS or DDoS, is all time it's saturating, right? But the way of the saturating is different from others. By saturating a target server with an overwhelming amount of packets, or a malicious actor is able to oversaturate server capacity, resulting the denial of service. Make sense, guys? So most of the DOS flood attack can be successful because the malicious actor must be more available than the target bandwidth, right? So why it's successful when any of the flood attack happen? Because the targeted same we are running a server in a network, right? So let's say this is our topology or network. So it has some limitation, like server has 16 GB memory, say 1 TB SDD, or say 4 core CPU or something like that. And the capacity of the total bandwidth in the networks, let's say 100 Mbps, right? So it's your network, say your network capacity is or 100 Mbps. So when those or flood attack happen, the DDoS happen, it's actually the uh, targeting from different sources, right? When we are talking about the DOS, right? So the targeting, say, let's say if in every target capacity has 100 Mbps, right? 100 Mbps of the capacity. So when more than 1,000 requests or attack happen from their network, then the capacity of the targeted network is overloaded, right? Then the service, normal service, will hamper. So that's actually the denial of the service. So that's actually the main attack, or main what we can say the category of the attack. That is the buffer flow or flood attack. And some others significant or historical flood attack we can also see in nowadays of real life, like smart attack, like being flood or being dead, right? Attack. So what is the actually the smart attack, what is the ping flood, and what is the ping update? We are coming into that topic in later or slide or next slide. So in short, a smart attack actually they previously expert DOS attack, in which a malicious actor utilizes the broadcast address of a vulnerable or network. Like if we check the smart attack, so it's like same. Let me draw a topology first. So this is your our network where it belongs for router, right? And they are connected to each other, right? So while we are in earlier network or earlier network devices, when router has connected to each other, but each router when we are setting IP address on the interface, let's say this is the IP 192.168.1. Sorry, 1.0 slash let's say 30. So in here we can use only two IP address, right? So that is 1 and 2, and another 2 address we can't use, that is the network address, and the last one, the 3, is the broadcast address, right? Address. So when a smart attack is happen, so it's actually uses the network address. How actually it's uses the network address for all of the services. It's kind of DDoS setup. Mainly the attacker attempts to flood a targeted server of the router using the ICMP. So ICMP means Internet Control Messaging Protocol. It's a protocol, right? So it's actually uses the ICMP to flood into that targeted router or devices in the network. By making request, they are actually using the spoofed address, the spoofed IP address. So what is the spoof IP address? So a spoof IP address, it's nothing but you can say it's the false address, right? So IP spoofing is the creation of internet protocol packet which have made a source address in order to either hide the identity of the sender or to impersonate the another computer system, like say when he is sending the request to this router or the server in this network, he actually hide his original address. Say this original address is 10.10.10.10, but when he's sending the request into the network or the device of the network, he actually spoof or hide his original IP address. So it's a technique of often used uh, by the bad actors when DDoS attack uh, happening in targeted device or the surrounding infrastructure or the network. So when sending and receiving IP packet is a primary way which network computers and others communicate and basis of the threat, right? Basically, all the IP contains header, right? Which the body of the IP header contains the source address, and if we know about the IP header, there is the option the source IP address and the destination IP address, right? So when the normal his the when he's changing the normal source address or requesting generating, then we call that the address scope address, right? So that is actually the main things how actually the attacker hide their IP address. So say how actually he or she spoke the IP address. So this is your server, and this is the legit user where actually you want to communicate these servers, right? So this IP address say 192.168.1.10. But when attacker try to communicate with these servers, he actually using his address to establish the communication or accessing those servers, right? So that's called the scoped address. So how we can protect actually the scope address? Well, it's actually we can't prevent the scope address normally, but we can measure some of the precautions or some of those things that can be mitigate the scope IP address. But in general way, we can't stop or we can't prevent the scope IP address. But we can do that by using the common best practice of the documents that we can use for our network and network devices. So how we can mitigate the scope address, we can mitigate those attack like a scope attack. We will check out that part on next slide. So now we know about the scope address, right? But when the smart attack happened, that mainly making the request with the scope IP address of the targeted devices to one or more computer networks. And how actually it happens, let's say this is your network devices, right? So actually, say this is the attacker. It's using the, say, let's say he got your public address and he uses the network of this address to scope all the networks, right? Then he's sending the request, all the network devices, and the request is coming back. Obviously, when someone requesting, then the server or the network devices will reply on that request, right? Then it's continuous when it's happening continuously on a network devices. The server traffic, potential traffic will be hampered or overrun the target or rendering is inaccessible, right? That means when it's continuously hitting on that network devices, right? It's actually saturated the network bandwidth, right? So how actually smart attack works. First, the smart mailer build spoof packet that has its source address set to the real IP address of the targeted uh, victims, or what can say the compromised users, right? So first, what he can do is actually the spoof the packet with the uh, with the source address and targeting the real IP of the network devices. After that, the packet is sent to the broadcast address of the router, right? We already said if the network devices say, let's say this is your public IP or real IP, and it has 0.168.0.0 network address. Then this network address and the broadcast address is 0.255. Then it's actually the packet is sent to an broadcast address of the router, which trans and request every host when is sending a request to the broadcast address is actually turn on sending request all of the devices that are under that network, right? So and increasing and also increasing the request by sending number of requests over there. And it's sending one request, say let's say this is your whole network, and it's sending a request to your broadcast network. It's actually if the network has 254 request, and request coming into that 254 request, and the devices must respond. If there is available, then the request must respond that request, right? When the request is coming broadly, then what will happen actually? The more say your device 254 all are getting the request, and request is coming one by one, right? Or increasing number of the requests in your network, right? So there's actually the second stage. First, he scope your address, scope your address, and sending our request to the broadcast address, right? Then what happened? Each device inside the network devices request from the broadcaster, then respond to the scope address, right? When is sending actually that's the false address, right? When is sending when network device is getting all the requests from the scope address, all the network devices also sending the echo reply against those requests, right? But that's the third stage of the scope attack. Smart attack. Then the network devices will send the echo reply. And the main when the network disruption will happen, when the request is overloaded for the network, then the network devices say I already said, say let's say your network capacity is 100 Mbps. When request coming or overloaded, or the volume and resulting denial of service, your network, right, is 100, so it's going to fall by the attack, right? So that's actually the fourth stage. It's fourth stage is network disruption, nothing but disrupt, right? So in this way, the smart attack happened. It's actually disrupting all the network right? So how can we actually mitigate this smart attack? So in earlier network devices, uh, uh, when router received a request from a network devices, right? So they actually respond against those network device, right? But nowadays, the broadcast address by default responding the broadcast address or sending request to the broadcaster is by disabled now network device, but earlier it was not. So several mitigation strategy for this attack have been developed and implemented over the years, what we can see nowadays. And the exploit is largely considered solved nowadays. Most of them on limited number of legacy system or what say, the old devices. Um, the mitigation technique may still need to be applied. So a simple solution is to disable the IP broadcasting address at the each network devices and the firewall. So main thing of this, we can disable the IP broadcasting address. That's the actually major thing. So how we can disable it in network interface? We can disable the IP broadcasting addressing in each of the network interface for the legacy net routers or layer 3 devices. But in nowadays, all the devices, the network devices are coming with the disabled IP broadcast addressing. So in this way, we can actually mitigate the smart pattern. Guys, make sense? Is there any question? I can take, actually, it's a theoretical. So if you have any question, you can raise your hand anytime. Ibrahim, can you take the question for every section?
Nusrat bhai, the participants, if you have a question, please press the raise hand button.
Okay, I got two questions. If there is a DOS or DDoS attack on a particular server, can the IP address of the device input in the attack be identified? Uh, Actually, the source attack must be identified, but means somewhere is what we can't identify the source address, right? But what we can do, we can identify the destination where who actually the compromised devices or the servers. So we can mitigate it for the time being. We can disable or limiting the service of the destination host to mitigate those services. So we cannot uh, identify the source code because I already said the attacker used the scope IP address. Makes sense, Ratul? I think you got your answer. With the scope address always same while sending request? Not. It's not the same address because it's scope address means I already said it's false address, right? So when sending attacker sending request from more than 1,000 places, right? Then the address not the same, right? Then attacker will use the different address, false address to the targeting server. How SQL inject is happened? We are coming to next, but it's kind of it's mailer or okay, we're coming to that part later. Shazul will answer that. You will answer, or you will get your answer end of this class. Is there any question?
So, Mr. Abdul Ahad, please ask your question.
So my question is that actually we do not define broadcast address in the network. Generally, generally we use the gateway and we define the network. So how attacker find out the broadcast address? We know that the last address is the broadcast address. So I think that he or she may find out the network. Yes, sir.
Yeah, if you got any address, we can assume that the network address, right? So if you got any public address, you continuously trying to find out the broadcast address, right? So when say you when you ping let's say 255 250 on your network, right? So what result you are getting actually? So you're getting something that your network are responding. You sorry, you find say okay. Let's say this is your uh, let's say this is your host address, right? And you are using /24, and the broadcast address of your network is 1.255, right? So when you have you ping in broadcast address ever, Mr. Uh, what's
Yes,
the name?
yes, yes, yes.
Ha- have you ever pinged the broadcast address
But broadcast address,
in your network? Have you ever pinged the broadcast address of it? So if you
no,
didn't do that,
no.
fine,
I
okay, I
think
can
that it is
explain
not
it.
possible to ping the broadcast address. He may be
Of course,
find out the gateway address.
it's possible to ping the broadcast address. Let's okay. Uh, let me show you.
Sir, another thing is that, sir, inside the network, it will be the private address, but the attacker will maybe find out the first the public IP address. Yes, sir.
Yeah, of course, public address. Otherwise, the private he don't know about the private address of your network, right? So
Yes, yes.
when the attacker is trying to compromise of your network, he will find out the public IP address, right? So let's say you are saying this is my the gateway and the IP address. Of course, it's /24. The IP broadcast address of the IP is 192.168.0.55,
255,
right?
255. Yes, yes.
So if I ping that, what will happen actually? Let's see. Requested timeout. If there is a filter or if there is no filter, actually it will resolve other devices of the is actually find out the other net devices hostess of this network. So that's the actually reason. So in nowadays, IP broadcasting addressing is disabled by default in your network. But when earlier devices or legacy devices, it was not. Then when you try to ping the broadcast as this, all the request is going back to the hostess of the network. You got the point? So
Yes, sir.
when
Yes, yes.
the attacker find a public address, right? You assume that assuming your network address is by a classless or classful, however, is there is lots of technique to find out your network, right? Or there are lots of things, right? So actually, the main thing is you will find your network address to compromise your network devices, and they use the IP broadcast addressing feature to exploit your network devices and the denial of services. Got it?
Yes, yes. My another question is that attacker always intend to attack the main router. They may not enter into the local devices, local
Yep.
maybe do
Yep.
not enter the LAN. Yes, sir. His
Uh,
intent.
Yep, it's intended to actually denial of the services, right? So the main focus. So when you got your any of the public IP address, it can be your router, it can be your network devices or servers, any of them. It can be any of them. It can be the border router. It can be or on your DMZ side. It can be anywhere.
Okay, okay.
Okay, guys. So we can resume our class. So that's actually the DOS and DDoS. I already said the DOS when the attacker is trying to uh, compromise or attacking from single sources that call actually the DOS, and DDoS already said it uses the multiple sources to compromise your or servers or network devices. So already said what is the buffer overflow and flood attacks, and the smart attack already said what is the smart attack, right? So another thing is the ping flood. So ping flood happen. It's actually it's same thing. It's the like ping flood is denial of service attack in which the attacker attempts to I mean overhauling a targeted devices with ICMP eco reply request. So the main causes of the targeted or main target of the or attack is inaccessible the normal traffic or disrupting the network services using the ICMP. And when the attack traffic come from multiple devices, the attack become the DDoS. We already said that. So how does actually the ping flood attack work? So the ping flood works actually. The attacker send many ICMP requests packet to the targeted server using multiple devices. When the ICMP request is coming any network devices, and the network devices server then send the echo reply or response against those requests to the devices that sourcing devices, right? But as already said, is when the IP address is scoped, the when the address is scoped or false, the request not actually going back to that sources, but what actually happening, the server or devices is busy with the getting request and sending the echo reply against those targeted. So how actually is happening? Let's say this is your target addresses or target devices. Say this is your target devices. This is the server. Let's say this is your web service, right? And there is the attacker. What we can say this is the bot. We are coming into that, but this is actually the attacker. So when a bot or attacker sending a request to the web server, the what will happen actually in normal scenario? The web server will sending back the echo reply, right? We know about the ICMP echo request, right? So this is the ICMP echo request. Guys, I think you know, all of you know about the how ICMP actually works. So when we ping, there is two things happening on the ping. First, when we're sending request, that is called the ICMP request, right? And when we are getting ping response, then it's called the ICMP echo reply. So that is the ICMP echo reply. So there is two things. First, the server is getting the ICMP request from the bot or attacker, whatever, or we can say, and against those requests, the server will respond the echo reply, right? So it's a normal scenario. If it's normal ping, like normal, we can if we ping from Windows, the 4 packet will all 4 requests will go into the web servers, and against 4 requests, the 4 echo reply will coming back into the source, right? This is the normal scenario. But when it's happen with lots of echo requests, right? Say you are sending thousands of echo requests to the servers, then what will happen actually? The server will respond against all of those requests, right? All of those requests. Oh, guys, just Oh, sorry guys, I had emergency call. There's okay. So what actually happening here? So when server is getting request echo request from any of the board or any of the attacker, then it's sending the echo reply is those echo requests, right? So when a thousand of million of ICMP requests coming into that server, then what will happen? Actually, the normal behavior of the server will happen, right? So actually, the what will happen? Actually, the main service will be hampered, right? So legit, then the legit request of the server will be hampered, right? So that's why actually the DDoS was happening using the ICMP or what we call the ping flood. So how actually we can mitigate the ping flood in island network? The common thing we can disable ping flood by disabling the ICMP functionality of the targeted router of the computer of the other device. By default, if you see, if we use the Windows server, Windows, right? So when we enable, when the firewall is enabling on the end devices like in your PC or desktop, we can sync from other devices to your devices, right? To achieving this, what we can do, we can disable the firewall. So what actually happening? It's actually disabling all the security features by default, right? So to blocking those ICMP false request or attack. So what we can do, we can actually disable the ICMP functionality of the network devices. So a network administrator can access any device of router, right? It can possible to access, but what administrator can't do, he cannot ping of the devices of the network of the or routers. So the consequence of this, that all the network activity that involve ICMP are visible, making the devices unresponsive to the ping request. So it's not actually the only the ping request, also the trace route of the ICMP also used for the trace route, right? So when we'll disable the ICMP functionality on network devices, then the ICMP and the trace route will not work, right? So in this way, we can mitigate the ping card attack in our network. Guys, make sense? So this is actually the ping flow. So another thing that the ping death is mainly a ping death attack is also the denial of attack, in which the attacker aims to disrupt a targeted machine by sending a packet larger of maximum allowable size, like causing the targeted machine freeze or crash somewhere else. So the original ping death attack is less common today, but a related attack known as ICMP flood attack is already discussed. So what actually it done in ping death attack is actually the sending the large number of packet with the ICMP request. That means say let's say uh, let's say this is the attacker. And this is the target device. So in normal scenario, what we can do, we are sending normal scenario, we can sending only the our default ICMP request, right? But when the shells activity happen, it's actually sending larger packets, like larger than normal, say almost let's say 10,000 or 100,000 bytes. By default, normal maximum size of the packet is 65,538 bytes, right? So this is actually the normal IP packets maximum size, right? But when malicious activity happen, or any machine need to be compromised by the attacker, then he's sending larger maximum size of the packets. So it's actually sending us, let's say, 1,000 bytes of the packet size to the target devices. When the target machine attempt to put that piece of a back target, the total exceed the size limit, right? And the buffer overflow can occur, causing the target machine is crash or the freeze. What we can say, it's the target machine will crash, because the normal behavior of the packet is it can possible to send up to 65,538 bytes maximum size of the IP packet, right? But when it's getting the request more than that, he cannot do anything of this packet, right? Then the request of the server, of the normal behavior of the server is hampered, right? So while ICMP code can be used for this attack, anything that can send IP data, that can say the UDP, can be used for this exploit. That also includes the TCP, UDP, and IPX transmission over there. So how actually we can mitigate this type of attack? So one solution to stop this type of attack, and check the reassemble process to make sure the maximum packet size constraint will not exceed after the packet is recombination. So another solution we can take to mitigate those attacks, that is create a memory buffer with enough space and handle packets which exceed the guideline maximum size, right? So what how the main thing that we can do, we can follow the best practices measurements for the network devices. So this is actually the ping that attack, and in this way we can mitigate this attack in our network. So we already learned about how the smart attack happen, and ping of death attack happen, right? So, and another lots of attack we can see nowadays in our networks, like HTTP fraud attacks, SYN fraud attack, UDP fraud attack, ICMP attack, right? So if we check that attack, it's kind of DDoS attack, but how the HTTP attack happened? So let's see, it's already included on that slide or not? Oh, okay. I've already included ICMP, TCP, UDP. Okay, let me just describe the HTTP attack. So HTTP attack, fraud attack, also the DDoS attack, but it's a and HTTP fraud attack is a type of volumetric DDoS attack. It's attack actually designed to eliminate a target server with the HTTP request. So once actually the target has been saturated, it cannot respond, or it unable to respond the normal traffic, right? So what actually happened? The denial of service or main normal behavior of the server will have got, right? So how actually it's happening? So there, in our HTTP is layer 7 protocol, right? So HTTP fraud attacker are the also the layer 7 DDoS attack. So layer 7 is the number of 7 layer of the OS reference model, right? So HTTP, when we are saying about or talking about the HTTP, it's actually based on the browser, right? So HTTP is the basis of the browser-based internet request, and it's commonly used to the load web pages, right? Or to send from contents over the internet. So let's say this is your web server. This is your web server. Let's say this is a web server, and this is your client, original client is requested. So when any client want to access your web server, he must open a browser, right? So the in browser, he will hit your website address, and the page will be loaded in your browser, right? So in this way, we can browse, right? And we can use the HTTP protocol to accessing this web server, or we can use the HTTPS, right? And security, but we are now talking about the HTTP. So in HTTP, which is the layer 7, right? So in order to actually achieve the maximum efficiency, so what actually the attacker do that it actually use the botnets. So how actually it's doing that? It's to doing the HTTP attacks. Attacker actually use the bot or it's actually uses the bot, right? So what actually the bot is? It's nothing but a software. Uh, it- it's okay. Let me first introduce you, all of you, what is bot. It's a bot is a software application that or a program to do a certain task, right? So bots are automated actually, which runs according their instruction. That means if you said it will run a certain period of time, or if you set the loop in this program, it will automatically doing that part, right? So without human intervention, or without human, it can run, right? So bots actually often imitate or replace human user behavior. Typically, they do or repetitive tasks. They can do them faster than human. So it's actually operate over the network more than half of the internet traffic, right? So what where actually bot is using mainly, we nowadays we can see the uh, mm, chatbot, right? So it's actually uh, conversation. Say let's say you are if you to any of the site trying to chat or conversation with your website, any of the service. So in there is no human behind those chat boxes, right? So the chatbot is actually simulating for human conversation and responding certain uh, phrases with the program by human, right? Another bot we can see nowadays, that is web crawlers. So that actually called the Google bot. So it's actually a useful bot that scan the content of the web pages when are trying to search something on the Google. And the web crawlers actually scan the content of the web pages all over the internet and give us in our search boxes, right? So it's the useful bots. Another another type of bots we can now see is like social bots and other bots. So in here, these bots are not look like this. It's not doing such activity that we used for social or web pages or chatbots, right? It's actually work for uh, malicious activity, right? So uh, uh, this also used for generating HTTP response or HTTP GET response. So in HTTP, when use the HTTP, so there can be two type of HTTP DOS attack happen on the network. First one is HTTP GET, using the HTTP GET, and another one is HTTP post. HTTP post, right? So these two type of attack can happen using the HTTP flood attacks. So what actually he'll do, attacker when HTTP flood attack happen, it's actually sending lots of HTTP GET request or get flood to the web servers, right? So what actually happening? The multiple computers or bot that's actually sending for the GET request to accessing the web images or what we can say some other access or files from the compromised servers. When the server is getting million of requests at a time, what will happen? Thus, it unable to process a million of packets at a time, right? Because there is the server has some capacity of it has some capacity. Also, network has some capacity. Then the normal or legit traffic will be hampered, and the denial of service will occur, right? So the GET flood actually request for getting content of the web servers, right? So in this way, the HTTP GET attack happen. Another attack happen using the HTTP. That is the HTTP post attack. Uh, Actually typically submit a website form, right? The server, each server handle uh, the incoming request to push or getting some data, right? Then the form designed to fill up by the other side. Then what bot do? He'll fill up all those form and sending the first attack, right? So how actually the process handle, or now we can handle the post attack. So nowadays we see when the server uh, use the captcha, when he use the any form or website of this attack, right? As I mentioned, the layer 7 is a complex, and actually it's multi bit, right? One method is to implement with challenge, right? When we use the website with the form, then we use the challenge key, right? When we use the challenge key or the captcha to test commonly whether it is bot or not, then we can actually mitigate those types of bot attack using the HTTP. So in this way, using the challenge key or the captcha or any other JavaScript challenge may mitigate the HTTP attack. Whether it could be get attacked or whether it could be the post attack. Make sense, guys? So this is actually the HTTP attack, so how happening in nowadays, and in this way we can mitigate the HTTP attacks. I think Ibrahim, can you hear me?
Yeah.
Sound not found. Amjad Hussain say
Yes.
or here.
Have you faced any problem?
Or difficult to understand, Tariq Hassan. Yeah, it's actually the theoretical. The security is commonly look like that because there is no proper way. If you read something about the HTTP attack, then you can relay on that part. But if you are not familiar with that part, it's look like a garbage. Now you are listening right now, right? So if you heard something like that in the first time, then it's actually very difficult for us to understand what I am saying right now, right? But I am trying to just give you an overview and the some kind of attack that is now happening in our real world. So that's all, nothing but.
Please, Nazar bhai, you can carry on.
Okay.
Just skip this type of message.
So another type of attack that is happening, that is the DNS plot attack. So DNS plot attack actually, why actually DNS is used to know about the DNS used to translate the IP to name and name to IP addresses, right? So it's look like your phone book, right? When we are trying to search a number, but we are not actually search the number. We are actually searching the name of the phone book, right? So in internet, the DNS is look like your phone book. When we are accessing any server, we are not placing those servers IPs on the browsers, right? We're just using the URL or website address to access those servers. So a DNS plot actually happening when the attacker use to compromise the DNS resolvers. So what actually happening behind that is actually a DNS where an attacker forces a particular domain's DNS servers is an attempt to disrupt DNS resolution. Nothing. So it's actually the disrupting the DNS resolution for that domain. So when the legit user are trying to access, it can or look up the address, like say this is your DNS server. So the domain of the DNS server is say, let's say example.com. So it has lots of lots of entries, a records, or lots of records in the DNS, right? So when somewhere else, when user trying to accessing any of those records or any of those entries, and then he will always only use the DNS server address, right? But what attacker do is just disrupting the lookup of these servers, right? So then what happened when the DNS server will compromised? Actually, the legit user cannot access those type of services, those of entries that handled by these DNS servers. So then the legit user unable to access those types of services, but what actually serving for this domain to the users. So the main function of the domain translate between easy to remember names, right? But hard to remember address, website address. So successful attacking DNS system makes the internet unusable the most for the most people, right? So when so let's say when we are okay. So let's say this is your network. So in your network, the users behind your network to accessing the any of the websites, they use what they do. They use the IP address, and also they use the DNS server, right? So when DNS will compromised, then what the users of the network unable to access the website of the or any other services, right? So actually, if your DNS is compromised, all the system will unaccessible for the internet, right? So DNS flood attack continuously a relatively new types of attack based on DNS that actually the risk of high bandwidth of the botnets. So mainly DNS attack occurs nowadays IP camera, right? IP camera, DVR boxes, IoT devices that actually used for the DNS, mainly for the DNS entry servers. So the volume of the request from the IoT devices is oversaturated than the DNS provided services and preventing legit users from accessing the provider DNS servers. So DNS flood attack not unlike the DNS amplification attacks, but that amplification attack reflects amplified traffic of unsecure DNS server, right? So main things is the DNS server or DNS flood attack is to compromise the DNS to disrupt others internet services who is actually using those DNS servers or DNS for accessing or browsing the internet services. So to avoid those DNS attacks, what we can do, we can actually uses mitigate many way you can mitigate, but in tradition we can use the secure DNS servers that also we can allow our DNS from a specific IP address where he's actually accepting the request, and we can do that actually. So we can actually limiting the target people who actually accepting the DNS requests. So in this way, we can mitigate our DNS attacks for our networks. So this is actually the DNS. And another type of attack we can see that is actually the sign attack. So sign attack actually the TCP attack or in other said. So in sign flood attack that also the denial service attack was the main target of this attack also the same. But how actually we happen on how actually it's happened. First, we know about the TCP connection, right? So it's a three-way handshaking. It's response against TCP sign, then sign acknowledgement and the acknowledgement, right? So it's a three-way handshaking. When if we know about the TCP, how TCP works. So if you see the TCP works, first he's sending the sign request. Then after that, the server will respond with signed acknowledgement. And against those acknowledgements, you're also sending the acknowledgement. So in these three-way handshaking, the TCP works. But in TCP's sign flood work, how actually works. The first, the client sending the signed packet request to the server to what initiate the connection, right? Then the server then respond to the initial packet with the signed acknowledgement in order to acknowledge the communication. Finally, the client returns acknowledgement the recipient packet, right? But demos the attacker send high volume of signed requests. Say this is the target server, and this is the bot or target devices. And what we can say the spook sign packet. Spook sign packet and spook sign packet. That actually what server will do, server will sending the sign acknowledgement, right? So when he's sending the sign acknowledgement, we know about the spook address. It's actually the false address. Then the acknowledgement would not actually reach the those addresses. The server are always busy with acknowledging those sign requests. Then normal behavior of the server will hamper when million of spook sign request coming into that server. So in what we can do, we can limit the sign packet or requests that any of the sources or the requests that can mitigate the sign attack, but not fully. But we can mitigate by limiting the sign request of the from the outside of the network. So, but if our server is providing the public service, then it's difficult to understand what is actually the spook address and what is the legit address. So sometimes it's very difficult to mitigate those kinds of sign attack now. It is, but now we can use look like IPS, IDS, such kind of devices, firewalls. There are injection files to mitigate that kind of to mitigate those kinds of sign request or sign attacks. So in this, the sign attacks actually happening for sending the spook sign packet to the servers, and the server or server getting more than million of requests at a time. Then main service of the server is hampering, right? So this is also the kind of attack that's called the sign flooding. So we actually learned many of the attacks like TCP sign attack or HTTP attack, ping attack, smart attack, right? So those kind of attack actually the smart DDoS attack. So I already said the spoofing attack, right? So before going to mitigate the spoof attack, uh, uh, we also try to learn something malware, spyware, or virus worms. Like it's a kind of uh, malicious activities that's actually occurring, hampering the network normal behavior. So, what is actually the malware? So we know it's a kind of malicious software. It's in general it's term which can refer or the virus, worms, trojans, ransomware, spyware, and other harmful software, right? So, in general, the goal of the malware is to disrupt the normal operations of the devices, right? So, the purpose or the disruption can range the purpose from displaying ads on device without consenting, gaining root access to your computer or network devices. So we can nowadays we can see many types of malware like spyware, viruses, worms, trojan horses, rootkits, ransomwares, like that. So is spare also the same, but as the name of implies, spare is used to spy on a user behaviors like what user is doing, what he's typing, what's actually the key. He's actually trying to record the keystrokes. So then he store his the user keystrokes and giving those keystrokes to the users. So main purpose of the spyware or spyware is to compromise the username password of a user that he used for accessing let's say internet banking or credit card or something like that. And Pydas is also kind of malware, but it's actually it's the it's all our program, right, embedded. This also can be embedded the operating system or piece of software, but the victim need to run operating system or open infected files, right? So it's a kind of infected files that actually compromised by or injected by any others. So that's virus once not unlike viruses, but once self-replicated and transmitted themselves over networks. But virus can't do that. So what can do? He can actually he replicate itself in the network. So user does not have to run any software become a victim like the viruses. So if in viruses, so the user must need to run a software, right? So, but in a worm side, the user don't need to run any of the software, right? So just being connected to the infected network to good enough to spread the worm. Yeah. So a Trojan horse is also another kind of malware. This piece of malware that comes hidden inside other useful software tool. So mainly when we use the pirate's copy of popular software, then it's may infected by the Trojan horses malware. Uh, and nowadays, so we use the rootkits to actually the cracking of many of the licenses, right? So actually, rootkit also the work of is a kind of the malware. So it's open mainly it's used to open the door for the attackers, and when it's he open the door for the attacker with the host and where the rootkit is installed, the machine will be compromised. So nowadays we see another kind of malware, what is called ransomware. So what actually it does, what this software can encrypt files or even entire operating system, all computer or network them encrypted until it I mean some of the uh, until the attacker get any amount. So the emergency of the nowadays we see the Bitcoin, right? The emergence of the Bitcoin and the other cryptocurrency to open those encryption, right? So nowadays it's popularity of the Bitcoin is popular because the popularity of the ransomware attack, as the anonymous attacker can accept currency to minimize the risk of getting caught by the cost. So what actually the ransomware is nothing but a malware. So now we know about some kind, or learn about some kind of malware like firewall worms, viruses, right? So to avoid, I already told about the spook attack, right? So to mitigate those spook attack, what we can do, we can use the Unicast RPF. So Unicast RPF is the process how actually we can mitigate the spoofing attack. So Unicast reverse path forwarding, that is the security feature to prevent those spoof attack. So what he can do normally uh, when our router receives an Unicast IP address, it's only care about the source address, right? Sorry, destination address, not the source address. So what he actually do, he's just matching the source address it belongs to belongs to the routing table or not. If it falls found the source address entry on the routing table, it passes the packets, right? So the if the IP packet has to be routed, it will check the routing table for the destination IP address, right? Select, then the router will select the correct interface and it will forward. So what actually we're getting here, when any of the packet is coming into your router, like say this is your router, and there's two interface, fast Ethernet 0x0 and fast Ethernet 0x1. So when any packet coming into the router, so what actually router do is just care about the source address. If the source address is in your matching with your uh, routing entry, he will pass those packets to the destination. Nothing, right? So in a spoof attack, in what URPF or Unicast reverse path forwarding do, it is prevent the spoof attack. Whenever he router receives an IP packet, he will matching the entry that belongs to the source IP address. If does not match, that packet would be discarded. So there is two mode. There is a two mode to mitigate the spoof attack. One is strict mode, another one is loose mode. So in a strict mode, he will check two things, like he'll check the two things. First is just matching the source in the routing table. Another things, the source what he is getting is to reaching those sources, if he's using the same interface or not. If it is matched with the same interface, then he will forward, and if not matching with the same interface, it would not, or packet will be discarded. So that called the string mode. So what we are getting here, so he'll just check, do I have the matching entry for or the source in the routing table? First, if it is yes, then the traffic, the packet will check the second stage. It is use the same interface to reach the source, that same interface to reach the source address. If it is matched, then the packet will be forwarded on passes. If you look into the example, like let's see, this is the interface that this is the router, and the IP of that is the 192.168.2.1 and 1.2. Okay, so the source address. Okay. Let's say this is the 3 router in here. So one router IP address is 192.168.12.0/24. Another is 192.168. Let's say 13.0/24 is point to point. And this is R1, this is R2, and this is R3. Behind the R2, there is a loopback. Let's say 2.2.2.2. To reaching this loopback, R1 has a static route that is 2.2.2.2. The next stop address is 192.168.12. Let's say 2. So when request R2 is sending request, sorry, R1 is sending request to R2. R2 is sending request to R1 using the loopback address. So R1 matching those entry. If it is matching the routing table entry, yes, it has, because the router has the route to reach the loopback address. So it matches match the first step, right, or first criteria. Then he will in strict mode. Then he will check the second criteria. So if what is the second criteria? The second criteria, do it use the same interface to reach the source? That means to reach the 2.2, is it using the same interface? If it is use the same interface, then the traffic will be passed. When we are trying to ping from here using the loopback to here, then the traffic will be passes, right? It will get response. But when we will trying to reach here using the spook address 2.2.2, what will happen? The 2.2 will found the 2.2 entry on routing table. That means first criteria is matched, right? But the second stage is to reaching 2.2, that the route is getting by a say fast Ethernet 0x0, but the request coming through the fast Ethernet 0x1. Is it this matching? Not. So when this criteria is not matching, the packet will be discarded. When we are trying to reach 2.2, reaching to from 2. Using 2.2 from R3. So in this way, your RPF actually works. If we check in real scenario, we can actually check that. So yes, we can check that. I think samples. Oh, when I'm trying to connect this site to show connection to this. It's trying to access the request. Okay. Some hypothesis or services meant to our service space. Okay, Saad Murshid Khan and Shiraz Islam. I'll coming back to that part. So I'll answer this one after the lab. Okay. So to check out the lab, I will open. So what our goal? Actually, we are submitting the URPF strict mode algorithm mode. So what this is R1. Let's say this is the R1 as this is R2 and this is R3. And the IP address of the that is connecting R1 to R2 that is would be the network 192.168.12.0/24 and the network connecting R1 to R3 is 192.168.13.0/24. So we'll set the loopback interface first on R2 that is 2.2.2.2, right? So to reaching the loopback interface from R1, we have to set the static route in R1, right? So let's configure the topology first, then we'll check your PF commands. Guys, wait for a while to booting the devices. I think it's taking lots of memories and CPUs. So just changing the images like yes, routers. Let's configure our topology first. So this is our router one. So I can change the router name one first. So what we will do first, we will set the IP address of the interface that is connected to R2. The IP address of the gig 0x0 would be 12.1, right? So interface gig 0x0. So IP address is 192.168.12.1 and the subnet mask of the P is 0. Then we have to paste the no shut command to up the interface. Another interface is gig 0x1. So IP address of the gig 0x1 is 192.168.13.1 and the subnet mask of the IP is 255.22.20 and have to paste the no shut command to up the interface. So if we now check the interface IP, do show IP interface brief. So see the two IP address already set on the interface gig 0x0 and 0 that is connected to R1 and R2. If we check the route table, see only R2 connected network is here. One is 13.0/24, another one is 12.0/24. So no route not set yet for the loopback interface of the two R2. So okay, I have to finish the R1 task. I completing those part of that part also. So IP route 2.2.2.2 to 55 to 55 to 55 to 55, and the next hop address is 192.168.12.2, the IP address of the R2 to reaching the 2.2. So if you check the route table now, show IP route. If you see other, now we are getting another route for 2.2.2. So then we'll configure the R2 configuration. So R2, first we have to change the host name. Host name is R2, and the interface that is connected to R1 is gig 0x0. So interface gig 0x0. IP address is 192.168.12.2, and the subnet mask of the P is 255.255.0, and the no short command. And if you check now the interface IP do show IP interface deep, we are now getting the 12.2 IP set on gig 0x0, but there is no loopback interface with 2.2.2.2. Then we have to create the loopback interface, that is interface loopback 0, IP address 2.2.2.2, and the subnet mask is 255.255.255. If we check now the interface, now I see the another interface is created, that is loopback 0 with the IP address 2.2.2. So that's our R2 configuration and the R3 configuration. So this is the R3. So, this is R3. So the interface has to need to configure, that is gig 0x0, that is gig 0x0, and IP address is 192.168.13.3. For our router 3, the subnet mask of the IP is 255.255.0, and also no shut command to off the interface. That is our R3 configuration, right? So if we now check the interface IP, Now see the 13.3 IP set on the interface that is gig 0 by 0. So now if you configure the URP on the interface, the way of configuring the Unicast reverse forwarding, that is URPF, that is the command we have to set on gig 0 by 0 and gig 0 by 1 on R1. So interface, if you check the current configuration of the interface, that is to show run interface gig 0 by 0 configuration check. See, only set the IP address on the interface, right? So then we have to configure just one thing, interface gig 0 by 0, the IP verify Unicast source reachable via RX command, and also at gig 0 by 1. So if we check the current configuration of the gig 0 by 0, you see the one parameter is set on gig 0 by 0, also on 0 by 1. So if now check from R2, okay, before going to check that part, if you check now the RPF parameters show IP interface gig 0 by 0 that include verify. That's set, right? The command is already set. Okay, now let's ping from R2 to using the loopback interface. So see, if the ping 192.168.12.1, that is the R1 IP using the source interface loopback 0, that part would be happen. So the ping is getting response, right? So ping is reachable. So we are getting response from 12.1. So if we now create a loopback interface on R3, same loopback interface on R3, say interface loopback 0, IP address 2.2.2.2, 255, 255, 255, 255. Actually, we are setting same loopback, same IP address on R2 and R3. Show IP interface. We see the 2.2.2.2 is set on R3 also. If we ping now, the ping 192.168.13.1 using loopback source loopback 0, what would happen? So you see the packet cannot reach or getting no response here. So what actually happened in here? See, if we say on R2, oh sorry, on R1, what actually happening here? Show IP interface gig 0 by 0. If we check the drop packet, you see the sub verification drops 0, suppression verification drop 0, verification drop rate 0 for gig 0 by 0. If you now check on gig 0 by 1, you see the verification drops 4, right? So actually, if, we already said the verify command on the interface, right? Or others, the IP address on a source IP address in the routing table and the source address that coming into a destined that is on the same path or not. So if it is verify or rectify those criteria, or if it is meet those criteria, then packet will be forward. Otherwise, it will drop, right? So now it's checking the verification. The in gig 0 by, on gig 0 by 1, it's the verification. It's dropping the packets, right? So that is actually the uh, strict mode of the URPF. So another mode we found in a URPF, or we can change the mode. There another is loose mode. What is the loose mode? In strict mode, we are getting we have to match two criteria, right? But in loose mode, we have to match only one criteria. That is the matching entry of the source IP address in the routing table. So what is how actually how we can configure and why actually use the loose mode in your IP? So loose mode actually configure when two one say R1 is connected two of the ISPs. So when the router is connected with the two ISP, there is a chance to asymmetric route. What is asymmetric routing? Same request or generating. Let's say the request or generating on the request or generating for R1 via R2. So let's say this is the internet, R2 connected and R3 is connected to the internet, and request going via the ISP1. Say this is the ISP1, this is the ISP2. When request going through the ISP1, but incoming request coming back into the R1 through the ISP2, that's actually the asymmetric route, because the route not getting the same path to the same path where when is I mean for sending or incoming request. So when there is a chance to or any of the router in the network where asymmetric routing will happen, then we have to configure the loose mode. Then we have to configure the loose mode. So how we can configure the loose mode? To configure same configuration is same, just we need to change the configuration on gig 0 by 0 on gig 0 by 1. So that is gig 0 by 0. Earlier, what earlier we set on gig 0 by 0, we set the IP verify unique source reachable via RX, only receiving or checking the receive packets, right? But in here, reachable via any, if we IP verify unicast sorry, I have to go under the interface gig 0 by 0. Then we have to check, or first we have to remove this command from here, and the IP verify unicast source reachable via any. The command would be the any for this command. So same way we have to configure the gig 0 by 1 also. So now if we check the configuration of gig 0 by 1 or 0 by 0, say see earlier it was only the RX, now we are setting any reachable via any address. So if you configure any, if server router is considered as a loose mode, and in this mode you will check only the one criteria. If it is match with the routing table entry, it will pass. So if you now ping from R1, sorry, from R2, you see the it's getting, and also R3 when not getting that. But if we check the interface configuration, show interface gig 0x0 include drop. So now see there is no verification drop on R1 gig 0x0 interface, and also gig 001 earlier it was 4, right? So if you check the gig one, you see earlier it was the verification drops were 4, but now it's not verification was not drop, it just surface the verification. That means it's forwarding the packets. Makes sense, guys? So in to avoid the spook address, what we can do, we can configure the URPF on our network devices using two modes. One is the loose mode and one is strict mode. So strict mode is actually checking the two criteria. One is whether it's getting whether it is getting using the same interface, or also source address in on the routing table. And in loose mode, it's just check only the routing table, whether source address is belong to that routing table or not. So that's all about the URPF and our today's lesson. So I think you guys, I think perhaps you got some idea about some attacks and how we can mitigate. And I earlier I said it's maximum of this lesson is theoretical, and it's difficult to understand all those stuffs in at a time. So that's all about for today. If you guys any question, you can raise your hand, or you can write down on chat boxes. Ibrahim, you there?
Yes, Nazim bhai, can you answer from the question answer box?
Yep. Where is
Okay,
the
just start, then I will give the permission of the participant.
So first, when I'm trying to connect a specific site, shows the connection request, somebody trying to access your password. Okay, Mr. Shaz, there is lots of events that can be causes for that. But most of the time when you're trying to access some of the application of the server and it's reducing the connection, it when main reason of the reducing the connection is the port is occupied. That means that or which port you are trying to access is not reachable, or when the port is inaccessible from a source you are requesting to. So and when somebody is trying to access your password or devices, that when are you getting this kind of messages, that means the device or the password is attacking from somewhere is using password cracking. There is lots of tool for password cracking, right? So there's two that can be two different thing, right? So connection refused occurred when in which port you are trying to access, when it's not unaccessible, or the host port is occupied by others, then you can get the connection refused, right? So how to mitigate those problems? So it's a when you have to ensure that how many ports, and let's say by default when server is sending a request, uh, okay, let me give you an example. So this is your server. By default your server can it's for this 65,535, if can more than 60 I mean 60 let's say 65,000 euros, so you can connect the source addresses, right? Remote requesters, you can connect 65,000. But when the server is getting more than that, then server will not handle those kinds of requests, right? Then you'll get such kind of request refused messages. Then what you can do, you can extend the servers for the application, then the port will be the extended, right? So what you can do, you can use LTM to forward, or load balancer. You can use the load balancer to load balance those services into your device servers. Then you will not get such kind of messages from networks. So at LTM or load balancer is the solution for not getting connection requests for the port occupied. So I think Mr. Shazul, you get your answers. Shad Mursid Khan, sometimes hackers use web service just to mine cryptocurrency from host PC. What kind? Uh, can you please recommend any action? So when mine attack or cryptocurrency, I already said this kind of nailer, right? So you have, for your host PC, you can use antivirus software. So actually, your host software is creating CNC with the servers, right? So when the CNC is created from your network, then it's actually connecting the attacker side to compromise your network, or something like that. So what you can do to avoid such kind of action for not creating the CNC with the bot, so you can use the antivirus software, or the network filter the ports that you are not using the network. So for the end devices, just you can use the antivirus software, internet software that can mitigate your problems. Hope you'll get your answer.